Hello, good morning, students. This is the second video of Introduction to C++. So we're going to be learning about C++. Okay. So in the previous video, in the first video, I discussed about the history of C++. Okay. I discussed about top-down and bottoms-up approach. Then, yes, I discussed in brief about the object-oriented programming paradigm also, and procedural programming. So today in this video we're going to discuss about the object-oriented programming paradigm. Okay, and what constitutes the object-oriented programming, or what are the different categories of the object-oriented programming paradigm. So let's move on. So object-oriented programming, or OOP, in short OOP. Okay? So it deals with the overall program design and not just the execution through the functions. Okay. In procedural programming, the program was focused on the logic, or the functioning, or the functions. Okay. The process of how the program was run. That means procedural programming was mostly function oriented. Now in procedural, the data is separated from the function that operates on the data. So in procedural programming, the data and the function that operates on the data were kept separate. Okay. Now, what is a program? So a program is a step-by-step instruction given to a computer. Okay. We are discussing about object-oriented programming, then procedural programming, right? So a program, it is a step-by-step instruction that is given to a computer. Okay. So your when you press the when you say 1 plus 1 and then you press the enter key, right? Now there must be a program written, okay, so that it will process that 1 plus 1 and give you 2 when you press enter. Okay, so such kinds of programs, okay, that is a step-by-step instruction. Okay, all of these programs are so most of these programs are written using this C++ and using the concept of this object-oriented programming, or procedural programming. Okay, so data and functions are kept in separate memory locations in procedural programming, but in object-oriented programming, data and functions are kept in the same memory location by an object. Okay, so we'll see what is an object in the following pages. Okay, so the data and the functions, okay, that is the data and the functions, okay, that operates on the data, they are kept in the same memory location through the object. So if you have a data that is 1 and 1, okay, and then the function is, okay, plus, so you have to do the sum of these two numbers, 1 plus 1, right? The data is 1 and 1, and the process is plus, that is the addition, the function. Okay, so in the object-oriented programming paradigm, okay, that both the data and the functions that operates on that data, they are kept in the same memory location using an object. Okay, so the data and the functions are not kept separate. Now, object-oriented programming models real-world objects. Okay, procedural programming, it's difficult for procedural programming to model real-world objects, but using the object-oriented programming paradigm, okay, real-world problems can be brought and solved through programs. Okay, so here's a pictorial diagram of the object-oriented programming with the object, data, and functions. Okay, so you can see here this an object. Okay, an object has its own data and functions to execute on the data. So you can see here three objects. Every object has its own data and every object has its own functions. So how does one object communicates with another object? It is through the functions. Okay, so through the functions, the object data can be passed on. Okay, so this is how in an object-oriented programming, okay, every object has its own data and its own functions. Okay, to execute on the data. So only through the functions the data can be passed from one to the other. Okay. Now, characteristics of object-oriented programming. Now, this is important, okay, but here in for this particular session, okay, this is just a theoretical concept. This uh, object-oriented programming, this will be learned in the later stages, that is in your senior years. Okay, so in this class 11 stage, mostly you'll be learning procedural programming. Okay, so this is just a small portion of what you're going to learn in next year. Okay, so this topic is just a theoretical concept, so practically it is not implemented in this particular textbook. Okay, so but still then it's better that you learn from now. Okay, so what is class? Class is a template for an object. Okay, so class is a template for an object, so it is actually a blueprint of an object. Okay, it is actually a blueprint for an object. So a class encapsulates the data and the functions of an object. So it means that, okay, the data and the function that belongs to an object, okay, is encapsulated by a class. Okay, is enclosed by a class. So a class, it defines an object, what the object will contain. And a class is a logical representation of the real world entity. Okay, so a class is a blueprint of for an object. Okay, like example I've given here, like school. Okay, student. Now student is a class. Customer in a bank, so customer can be a class, bank can be a class. Okay, and suppose a class name called dog. Okay, so dog here is a class name because the word dog is used to represent all the different dogs, different breed of dogs, right? You have a short dog, you have a tall dog, like that. Okay, different colors. So those are the breed, the size, the colors, all they are the properties that is attached to the dog. Okay, using these properties, or they are called as data members. Okay, using these properties, okay, you can identify a dog. So that is the characteristics, that is the breed, size, color, that is the characteristics of the dog. Okay, so dog, the word dog is a class name which is used to represent all the different breeds of the dogs. Okay, having different size, having different colors in general. Okay, so a class is a logical representation. You can say it is theoretical representation. Okay, in a theory or logical representation. So using that only, using that class only, you can define an object. You can create an object. Okay, so again, you have the methods sleep, run, eat. All dogs sleep, all dogs run, all dogs eat, right? So these are the functions, okay, through which, okay, a dog behavior can be identified. A dog sleeps, a dog runs, a dog eats. Okay, and using these functions, okay, or using these methods, okay, the properties of the dog can be processed. Okay, so with a class, many objects with similar members can be created. So when you have a class like dogs, you can create many objects of dog. You can create many dogs objects having the same properties, having the same methods. Suppose like the class name is dog, and you have suppose like objects, say like three dogs, dog 1, dog 2, dog 3. Now dog 1 breed is different from dog 2 breed and dog 3 breed. Okay? The size is also different, so the color is also different. Though the dogs are different, yet they all share the similar members, or that is the similar properties and the similar methods. They all sleep, they all run, they all eat, they all have a different breed, they all have a different size, they all have different colors, or maybe same colors, like that. Okay, so Class, just keep in mind, it is a template, it is a blueprint of an object. Example like student also. Okay, student. Student is a class name. Now it represents all the students in all the schools. Okay. Now if suppose you have to select student of a particular class, suppose like class 11 students, right? So suppose there are 10 students in class 11. So if you have to write down a program for that, okay, so the class student, that is the class name, okay, and if you have to create a data for all the students, an object for all the students will be created. So 10 objects, that means like student 1, student 2, student 3, student 4, and so all the students will have the same properties, which is like, okay, roll number, name, age, phone number, right? And suppose like they will have the same methods of functions like studying, sleeping, okay, um, so on. Okay, so these are, since they have the same members, okay, so they can be grouped together. Okay, now objects. Objects in real world can be represented by using objects in program. Okay, so an object is an instance of a class. That means an object is, you can say it is an example of a class. Okay, an object consists of properties and methods to manipulate on the data which is defined in a class. So object is the physical representation of the class. So a class is a logical representation, and the object is the physical representation. What I mean is, okay, object is your theoretical, okay, and the class is the theoretical idea that you have, and objects makes it come alive. Okay, so here properties are the data members. Okay, when you talk about the word properties, they are called as data members. Okay, that represents the characteristics of the object. Okay, like we discussed about the breed, the age, the color, so those are called as data members, and they are called as properties. Okay, so methods here, they are called as member functions. It performs an action on the attributes or properties, which are also called as data members of the object. Okay, so here an object could be a person, place, or thing. Customer is a class name. Okay, and here suppose like a class name customer, okay, in a bank. Now, and each customer account is represented by an object, or student is class name, and John is an object of class student. Okay, so if you have 10 students, okay, all the 10 students name will be represented as the object. Okay, and in the, suppose like customer in the bank, every customer's account ID will be represented as an object. That is how they will be identified. Okay, now data abstraction. Abstraction refers to the representation of only the essential details of real-world objects in the program. Okay, abstraction hides the unnecessary properties or attributes from the user. That means uh, it does not include the background details to avoid complexity for the user. So I've given an example here. Okay, customer account of a bank. Now, customer data which are relevant for bank works are stored, but not all details are displayed in a bank passbook or through ATM. Only essential details are shown to user. Okay, so abstraction, it refers to it displays only those details, okay, about the properties or the attributes, okay, to the user. So the background details or are not shown, okay, to avoid the complexity for the users. Okay, like in the example that is given here for customer account, right? Now, while creating an account, the customer has to give lots of details like address, phone number, okay, Aadhaar, PAN card, and all those things, right? But in the passbook, okay, suppose in the passbook, not all of those details that were submitted by the customer is printed out, right? The only thing that is given is the phone, suppose like the phone number, okay, the customer name, okay, and then the address, okay. the withdrawal and balance deposit, all of those things only are shown. Okay, or even in ATM also, the customer only needs to see, can see only what he needs to see. Okay, so certain essential details are kept hidden. Okay, and only those details which are needed to be displayed are shown. Okay, so that is the concept of data abstraction. Okay, or you can also talk about say like, suppose you have the watch. Okay, you have a watch, and so if you see the watch, okay, suppose a non-transparent watch. Okay, so you have a watch, and then, or a digital watch. Okay, now you can see the digital numbers on the watch, but so you can see the digital numbers on the watch, and by that you can judge the time. Okay, now it's 4 o'clock, now it's 5 o'clock, like that. But inside how it works, you don't know, and you don't need to see. Okay, you only need to see how the time. Okay, so to avoid the complexity, okay, so only the time is shown. Okay, the details about how it creates or generates the time is not known to the user. Okay, now encapsulation refers to the wrapping up of data and functions which operates on the data into a single unit called object. Okay, though a bit similar, okay, but encapsulation is different from abstraction. Okay, now in terms of encapsulation, okay, the data and the functions that belongs to the objects, okay, are wrapped together by the object inside a class. Okay, it hides the information details using the access specifier, which we will learn later on. Okay, now right now it's purely theoretical. Okay, you might not understand much of this detail because this only a small topic is explained here. Later on in class 12 only you will understand all of these topics like encapsulation. Okay, so what is access specifiers? Okay, so thereby protecting the properties of the object, it prevents free access to the data with an object. So access can be done only through the methods of function. It is referred to as data hiding. So the access to the object data, okay, can be done through the functions only. Okay, so the datas are kept hidden. That means certain important datas are kept hidden. Like suppose like in the customer account in a bank, right? Okay, customer account in a bank. Suppose like an example for like uh, if you if you need to access through the ATM, right? Okay, you you need the customer can access the details only through the card, debit card, and provided the correct data is entered, the pin code is entered, right? And only then the transaction can be done, the deposit, the withdrawals can be done. Okay, so that is the data remains hidden. Suppose somebody you lost your card, somebody recovered your card, okay, and tries to access it. The pin code is not, the pin code is unknown, right? The pin code is hidden, so that's why it's not able to access it. Okay, so just a practical example of how the encapsulation works on data hiding. Okay? So inheritance. Inheritance is the act of deriving a new class from an existing class. Okay? The class, it acquires the properties and behaviors of another class, which enables code reusability. So the main advantage of inheritance is actually the code reusability, because from one class to another class, okay, the properties and the behaviors, that is the the datas, okay, the data in the functions are inherited uh, from one to the other. Suppose like in this particular example, mammals. Okay, so here all dog, cats, cows, and whales, they are under the category mammals. They are derived from the class mammals. So dog, cat, cow, and whale. Why? Because they do not lay eggs, they all give birth to live young ones. Okay, similarly, suppose a practical example, suppose like you have curly hair. Okay, you have curly hair, and And let's say that you have uh, you have a curly hair and maybe you have a very light skin tone, okay, but both your parents have straight hair and both your parents have, let's say, somewhat a darker skin tone. So how is it possible that, okay, both your parents have say, like straight hairs, but you have curly hair, and both your parents have darker skin tones but you have fair skin tones? It may be because that, okay, one of your grandparents may have a curly hair and the skin tones may be mm, fair. Okay, so that was that may have been inherited by one of your parents. Okay, and then that was inherited again back to you. Okay, so that is the concept of inheritance. Okay, now polymorphism. So polymorphism refers to the ability of an object or function to take on multiple forms. The function can be of the same name but functions in different way. Okay, so the functions can be of the same name but functions in different ways. Okay, so here example, a customer in a bank can have a different characteristics. He can be a father, a husband, an employee. Okay, so in a suppose like the customer in the bank, okay, so he is a customer in the bank, but uh, he is also a father. He can also be a father, he can also be a husband, okay, and he can also be an employee in a different company. Okay, so that is the example of polymorphism, where one object can, here customer can be, here customer is suppose like an object, okay, where one object can take different forms in the program. Okay, so these are some of the characteristics of object oriented programming. Okay, yes, this is a purely theoretical concept. Okay, you will not understand much of it from this topic. Okay, but later on in the later stage you will understand, you'll come to know about this one. Okay, so for the time being you just focus on the definitions of this. Okay, so that will be all for today.